Last time we discussed quadratic functions and equations. Now remember we talked about how they are any function or any equation that can be written in the form ax squared plus bx plus c equals f of x, or we can call this y, or many times this is set to a constant like 0. Now as long as we have it in this form, we can make a graph, and it will graph into this shape, a parabola. Now this shape has what we call a vertex. It's kind of a starting point, a middle piece. This vertex is helpful if we know the vertex form. Okay? The whole parabola kind of stems off of this vertex. We can find the vertex using our standard form, and we talked about that last time. We can also find it from this vertex form. It would be at hk. So if you can manipulate this form into a times the amount x minus h squared plus k, you can find this vertex at hk. We also talked about how we can use completing the square. Again, that was one of our ways to go from the standard form to the vertex form. And we discussed how to make graphs. Again, like graphing this parabola and finding the vertex. This week, we're going to talk about solving some of our quadratic formulas, quadratic functions. One thing we need to review is just a basic algebra property called the zero product property. Basically, it says anything multiplied by 0 is 0. So put in a general form, any number, and I'm going to call it a for any number, times 0 will always equal 0. Or, if we flip those around, 0 times any number will always equal 0. So, again, in a generalized form, if you have two numbers, a times b, and they equal 0, well then you can figure out then either a has to be 0 or b has to be 0, right? One of these two has to be 0 if our answer comes out to 0. It's a zero product property. When the two numbers multiply and they have a product of 0, one of them must be 0. So, looking at examples using our zero product property, instead of using a and b, I'm going to use these two binomials. Here is our a, here is our b. These are being multiplied and they come out to 0. What this tells me then is either this chunk equals 0, so either x plus 2 equals 0, or this chunk, x minus 7, equals 0. Let's pretend it was this x plus 2 that equaled 0. If it is, then we just subtract 2 from both sides, and we would get that x has to equal negative 2. That's one possible way for this to be correct. If I plugged in negative 2 right here, negative 2 minus 7 is negative 9. Negative 2 plus 2 is 0. 0 times negative 9 is 0. This is one way to make it work. On the other hand, if it's negative, or the x minus 7 that equals 0, then we would add 7 to both sides and get that x equals 7. If I plug in 7 right here, 7 plus 2 is 9. 7 plus 7, or sorry, 7 minus 7 would be 0. 9 times 0 would be 0. So these are your two options. Either x is negative 2 or x is 7. So in the end, you would say, these are my answers. X equals negative 2 or 7. Okay, those are the two ways to do it. You could also write it with a comma. Now notice, this comma is not saying, I'm going to use black, I'm not saying 2, 7 like this. If I wrote it this way, this would be telling me this is a point. We're at the point, if I had a graph, negative 2, 7, right there. This is not a point. So we don't actually use those parentheses to say anything. Actually, I think I just swoop around. Click, there we go. It's just saying your two x values are either negative 2 or 7. Let's look at another example of the zero product property. Same thing, I've got two binomials set equal to each other, or sorry, two binomials being multiplied set equal to 0. So we're multiplying this chunk by this chunk equals 0. So again, either this first chunk in blue has to equal 0, or this second binomial in green has to be 0. Okay, those are the two options that would make this true. So if it really was this one, this 2x plus 8 that was set equal to 0, we would subtract 8 from both sides to get 2x equals negative 8. Then we would divide both sides by that 2 to get that x equals negative 4. So x equals negative 4 is one of my solutions. If it was the other one, if it was this 5x minus 7 that was set equal to 0, then again I'm just adding 7 to both sides to get 5x equals 7. Then divide both sides by the 5 to get x equals 7/5. And you can leave it as a fraction. If you want, you can call it 1 2/5, or you can call it 1.4, that's fine, but it's alright just to leave it as this fraction 7/5. Okay, here was one of my options, here was the other option. So again, it's saying there are two different solutions, either x is negative 4 or it's this 7/5. Now note, the zero product property will only work for you if you have a multiplication expression that's set equal to 0. If this was not a 0 and it was, say, a 3, this times this equals 3, the zero product property doesn't work, right? We can't set this to 0 and this to 0. They wouldn't equal 3. You have to have two binomials multiplying to make 0. Get rid of this. Then you can use your zero product property. So why does our zero product property help with quadratics? All of our quadratics have x squared, right? So what does that have to do with two binomials? Well, our quadratics can actually be written as the product of two binomials. So if this was a binomial, I'm going to show you why or how this works to put it into a quadratic form. We can FOIL this out. X times x is x squared. X times negative 2, negative 2x. 5 times x is 5x. 5 times negative 2 is negative 10. We would combine these two and say that y equals this x squared plus 3x minus 10. Notice, this is a standard form, ax squared plus bx plus c. This is a binomial form. So these two really mean the same exact thing. They're just different forms of the same equation. If you graphed them out, they would make the same parabola. So we have a standard form, we have a vertex form, and even this binomial form. Now, using our binomial form, this x plus 5 and this x minus 2, that helps us find the x-intercepts. So in this graph, you see your y-axis and your x-axis. This plus 5, we would figure out that, okay, if we set this equal to, get rid of that and call it 0, use my zero product property, x would be a negative 5 or x would be a positive 2. Notice, x-intercept at negative 5 and positive 2. Okay, now of course, there's a whole other piece, right? There's all of these other spots for our equation, but we would know that in this binomial form, it is telling us these two spots. In the vertex form, it'll tell us this spot, right? So we can use our two different forms to help us find different pieces. And then in the standard form, also you can find this spot in there somewhere. So each piece, each form, will tell you different things about this parabola. The binomial form, it's these x-intercepts. So how do we turn a standard form quadratic into a product of binomials, or into our binomial form? Answer, we factor. So we're going to use the AC method of factoring. Now, when I say the AC method, remember from a standard form we have ax squared plus bx plus c. So the steps for the AC method of factoring, you're going to start with a times c. Whatever coefficient is here, times the constant at the end. Once you have a times c, then you need to ask yourself, what are the factors of AC that add up to make b? Once you know those two factors, you're going to split this bx into those factors. And again, those factors are just going to be coefficients times x. Now we factor the expression by grouping the first two terms and finding the greatest common factor. then grouping the last two terms and finding the greatest common factor. Lastly, we rewrite it as two binomials that are multiplied together. Now, again, just looking at the directions might seem kind of goofy. Let's try it out so I can show you what I mean. So we have the AC method example. We have 0 equals our x squared plus 3x minus 28, and we need to solve for x in this example. So questions you need to ask yourself, what is a? Well, in this case, a is 1. We have a hidden 1 coefficient here. What is b? b is 3. It's our positive 3 in this middle term. What is c? Be careful, it is a negative 28. We don't call it 28, it's negative because of this chunk here. So, first step, we multiply a times c, which is 1 times negative 28, and we get negative 28. Next thing I need to do is think of that number, negative 28, and ask myself, what are all the factors? So 1 and negative 28, negative 1 and positive 28, 2 and negative 14, negative 2 and positive 14, 4 and negative 7, or negative 4 and positive 7. Right? These are all the pairs that would multiply to make negative 28. Now I need to think to myself, which pair, which set, would add up to make this B 3, a positive 3. If I added these two, I'd be at negative 27, positive 27, negative 12, positive 12, negative 3, positive 3. Here, oops, I need this marker. This is my pair that adds up into 3. So my next step is to take my original expression, the quadratic. I'm going to split this 3x into two pieces, negative 4x and 7x. I got the negative 4 and the 7 from this pair. Now that I have split it into 4 separate pieces, I'm going to look at just 2 separate chunks, the first 2 terms and the second 2 terms. So we group them together and we start factoring. Out of these first 2 terms, I can take out x. Out of these second 2 terms, I can take out 7. Now, the reason I took out 7 and not like a negative 7 is because when I took out x over here, this term, this group, was left with x minus 4. So I needed to make sure this one was left with an x minus 4. So these two are the exact same thing, x minus 4 and x minus 4. Now I have an x plus 7. So our distributive property would tell us that this is the same as saying x minus 4 times x plus 7. Right? It's like we did a double distribute or a FOIL, and this is the same as this up here. Now that I have it as the product of 2 binomials, I just put that back in for my quadratic, and I now say 0 equals x minus 4 times x plus 7. This equation, this version of it, means the same as this one. So all we did was convert this into 2 binomials, which tells us that either x minus 4 equals 0 or this x plus 7 equals 0. If it was x minus 4, then I just add 4 to both sides. If it was this x plus 7, I would just subtract 7 from both sides and say that either x is 4 or that x is negative 7. So my answer is x is either 4 or negative 7. And that's how we would solve it. Again, factoring first and then using our zero product property. We're going to do another example. In this case, though, your a is not 1. Now, a lot of times we run into our standard form where our a value is 1 and things just go way easier. Now, sometimes you won't have an a value of 1, so we're going to try an example where it is not. We have negative 2x squared minus 7x minus 6. Your a value is negative 2. Your b value is negative 7. Your c value is negative 6. All we're going to do is the exact same process to figure this out. Multiply your a times c and you get negative 2 times negative 2 is positive 12. Or sorry, negative 2 times negative 6 is a positive 12. Positive 12 we break it apart to find all the factors. 1 and 12, negative 1, negative 12. 2 and 6, negative 2, negative 6. 3 and 4, negative 3, negative 4. Which pair would add up to a negative 7? Again, it happens to be this one at the end, negative 3, negative 4. What do we do with that information? We split our original quadratic. We find the middle term b, and we split it into that negative 3 and negative 4. So negative 2x squared minus 3x minus 4x minus 6. Group together first two and the last two terms. Once they are grouped, you say, what can I take out of these two? Now again, notice, I decided to take out a positive x. I could have also taken out a negative x. That would have been okay to take out negative x. That would still work. If I did, negative x would be out here, and these two would both be positive. Now, if I did that, maybe I should write that off on the side. I would have negative x times 2x plus 3, which means my other term over here should be 2x plus 3. If it was 2x plus 3, what could I take out of this to make it say that? I would have had to take out a negative 2. Okay, so we're going to look at two different options to factor this one. I rewrite this version as negative 2x minus 3 and x plus 2. X and 2, negative 2x minus 3. Okay, so I would say 0 equals all of this. Now again, if I used my other option, if I did it this way, I would have written 0 equals positive 2x plus 3 and negative x minus 2. These look a little bit different, but they're actually the same, and I'll show you why in a little bit. Actually, I can just tell you, out of this, we can factor out a negative 1, and we just take the negative 1 and times it here. That's why these ones look similar, but not the exact same. From this form, we know that either negative 2x minus 3 equals 0 or x plus 2 equals 0. If it was this form, I would add 3 and divide by negative 2. So x could be negative 3 over 2. If it was this form, I would subtract 2 and get x equals negative 2. Okay, I want to look at these forms then. If I had this one, I would add 2, so negative x equals 2, and divide by negative 1, so x equals negative 2. Same as what we got here. So this and this will give you the same answer. If it was 2x plus 3, I would subtract the 3, so 2x equals negative 3, divide by 2. Negative 3 divided by 2 is negative 3 over 2. So this one would be the same as well. So again, you can see why this option or this option, they'll give you the same answers. So in the end you say, all right, x equals negative 3 over 2 or negative 2. Those are my two answers in this case. So that'll cover it for video 1. We talked about the zero product property. We talked about how that can help you find your x-intercepts of a quadratic function using your zero product property. And we talked about using the AC method of factoring to turn a standard form into the product of two binomials.